to record. So let me go to Triola tables and see how this works. So we have this little tables, and on the second page of it, on the bottom, we have the so-called levels of confidence. And I asked you to find the z-score that correspondent to the level of confidence of 99%. And that means that our z-score is coming right out of this table, and that's 2 and a little assumption, it's 2.575. In fact, that's a very popular level of confidence if you want to be very sure that you did find probabilities correctly. Then if you're 99% confident, that's very good. We also had 90% and 95%. Those are not bad, but 99 is better, right? And the way the whole process was working is we had a confidence level or a probability of 99% that is always posted in the center. So level of confidence, 99%, that's like a probability. So what remains will be just 1%. That is composing two so-called tails here. There's one tail and there is another tail. And when I see they're equal, because picture is symmetric, I break this into two. So this will be 0.005. I'm just giving an explanation why this is 2.575. So the point is I need to find 0.005 among my little areas. So if I start at the top and keep going down, I will get the row with 47, which is pretty close, but 0.005 appears right here in the middle of 51 and 49, right? It's like 0.050. It's right in the middle, and that's why we have this asterisk thing. And that's why we actually take the average. So in between 70 and 80, it's 75. That's actually what happens when you put these numbers together. So you get negative 2.5, and then the place of hundreds will actually be giving us a little bit more than hundreds. It'll be 75, and that's exactly what we have here. So we got a positive 2.575 and a negative 2.575. So use of the tables is what we've been doing for a while, and we don't go any farther of this, and actually this number appears on the bottom here. So the asterisk brings us to this 2.575. So looks like we have this process, and I will go back to the textbook, and I want to look at section 6.3. Then I will return to section 6.2, but I think that section 6.3 will give us a better, actually more familiar formula that says x minus z times sigma over square root of n. I think last time I also tried to derive this formula to estimate the population mean. And on the other hand, I'm going to have plus this term, z sigma over square root of n. So I'm looking at the section 6.3 because I think it's a little bit more familiar stuff compared to 6.2, but then we'll look at 6.2 next week. We also have X bar here because we are trying to estimate population mean by using the sample mean. So I guess all we need is just to take a look at the exercise and things will go pretty straightforward. So I'd like to take a look at the exercise that actually asks us to find the so-called confidence interval. And the exercises, I think, appear here in the page, starting with exercise number 11. So let me try to see what they want in this entire group of problems. Looks like it says confidence interval is what they want to find. So I'm going to try to find a confidence interval. I'm going to use exercise 11. Let me write it here down below so we can see how we use in this formula a very straightforward way. So in this exercise, they say the sample mean is 524. Then we also have a standard deviation, which is 2.5. The standard deviation is 2.5. Well, they say it's sigma, so sigma or S, I guess, doesn't matter in this case. Sample size is 25. And then we also have that our level of confidence is 90%. Confidence is 90%. So when I know that the confidence is given here, it is 90%, then I get a z-score. So whenever you have a level of confidence, then right away you get a z-score that comes out of table. Remember, we just had this for the quiz last time, so the little table on the bottom has them all of these levels of confidence that we're going to use in here. So for 90% level of confidence, I got 1645. Okay, 1645 is what I take, just like we did on the quiz last time. And please notice that now I can plug these numbers in my left end. There are 4 numbers here. And also same 4 numbers I can plug into the right end of this interval, but the only difference here that we have a plus. So left and right ends are pretty much the same. And that's why we really care only about one side, because then you can just modify a little bit your calculation and get the other side. So even though the formula does not look very attractive, but when you start to see what is being used here, all these means, standard deviations, sample size, that's an old familiar story, z-score. So when I plug this in, I get a left end for the interval. And on the right side, I'm going to get the other end. So let me use the scientific calculator and put it right in. So I put scientific calculator. And then select decimals, right? The favorite. So let's do it. 5.24 subtract 1.645 times. We have 2.5, which is divided by a square root from 25, which is 5, but I can just put this in. So I got some number. Let me write it down. This is so-called left end of the interval, which is something like 4.417 ... Left end. And now I'm looking at the right end of this interval. And notice that all I need to do is change that minus with a plus. So what I can do is just highlight that minus, delete it, and put a plus. And get the right end of this interval, 6.62 dot dot dot. So we just made an estimate based on that sample for the average for entire population. How about that? Population mean was estimated. Well, it's Alex, so is that 4, is that 6 or 5? Well, with a probability of 90%, we have this average in between 4.4 and 6.06. So it is pretty good estimate. And in fact, people usually go with the worst case scenario. What does this mean? Well, let us read this in a little bit more details, and we'll see right away which value I can try. So we have the using remote by mails during commercials. So if you're selling commercial, then you want to make sure that your commercial is being seen, right? So it's not somebody just turn it off or switch the channel right away. So notice the worst case scenario is 4 seconds, 4.4 seconds. The best scenario for you is 6 seconds. So it tells you a lot. It tells you that your sizzle for the commercial should be within first 4 seconds. So if you extend it for over than 6 seconds, then most likely the channel will be switched by some male with a remote, and nobody's going to see that commercial at all. So make sure that 4 seconds, again, the worst case scenario, is utilizing your main idea. And then if people like the story, then they will probably continue watching it, but 4 seconds is what you need. So even though you don't get exact number, but it gives you a very good estimate for entire population. And that's actually a powerful thing. You can start from there your process of getting the commercial shot, right? Let me do another exercise, and we'll see that the formula that seemed to be kind of nasty on one hand is not really that bad, because we actually see that we can utilize it. Let me try 24 head circumferences for babies. So let's say in the nursery, they want to identify baby growth patterns that are unusual, so they considered 100 babies. Okay, so let us start with number 24 exercise that works with a sample size 100. Then what they did is they found a mean as 40.6 cm. That's centimeters, whatever it is. They measure it some unusual way, I guess, so nobody understands what this means. Well, inch has 2.5 centimeters approximately, so you can divide this by 2.5 and see how many inches this is going to be. Or you can put in a Google, you can always say convert 40.6 centimeters to inches. It will give you a result right away. Standard deviation sigma is 1.6. Okay. So they want to know 99% confidence level. Oh, confidence 99% is what we just utilized in the quiz, right? From last time. It gave us z-score of 2.575. So the z-score is here, and looks like that's all I need to use that formula once again, the same exact formula, just a little bit different numbers, but the calculator doesn't care. The calculator works with any numbers whatsoever, right? So let us work with those numbers. Let us put them in the formula. So X bar is 40.6, right? Minus Z is 2.575. Okay. Multiply it by the standard deviation of 1.6 and divide by a square root of n, which is a square root of 100. So I just put these four numbers in a formula the way I did in the previous exercise. And now the same exact numbers will be plugged into the formula, but instead of minus, I'm going to have to use plus. Instead of minus, I use plus. That's all it is. So it's a calculator time. So my goal is to make sure that you realize that all problems are similar, just different numbers by the same formula. So it's not like in the probability chapter where you had to use different formulas and maybe think too hard about this. No, now you just get the straightforward question, and on the final exam, I will tell you where that question is coming from what section, so you will know for sure what formulas you need to use. So all you're going to need is just plug numbers in a formula. In fact, our final will be pretty soon, in 3 weeks. Did you know that? So I got the left end here, 40.188. That's my left end when we subtract it, right? So now we're going to add, now we're going to highlight the negative and change it with a positive. So you got a positive. So I just put a plus and get 41 and little something on the other side. So this is my confidence interval, and that's all they wanted. So I gave them the estimates. So then based on what's the worst case scenario, they want a smaller size baby's head or larger size, that depends. I have no idea where they actually use this, but if they want to know the worst case scenario, the head is big, the biggest is 41, so that could be the average. Or if that's the 40, so if somebody measured the head and said, oh, this baby has 39, so the head is too small, so well, that's gonna be not the average, below the average. And that's the idea. But the point of story, you'll find those confidence intervals, and that's all it is. We get those intervals and utilizing this formula that looks kind of nasty, one can say, but not really, because it is not a bad formula. It's a nice little formula. So today I don't want to continue with this. I don't feel well. I have been vomiting all day and I don't know, some kind of infection or whatever. So I'm going to just tell you a few words of what we are going to cover next, and then I'm gonna let you go today without a quiz, because I don't think I want to spend any more time right now, because I again have some not very pleasant feelings in my throat. But anyways, I sure over weekend I'll get over that. So anyways, thank you. I hope I'll feel better. I will. So anyways, looks like we are dealing with chapter 6. So my goal is not to hurry. So we looked at section 6.3. Thank you. And then we're going to look at section 6.2 next time on Monday. Also, I'm going to be dealing with chapter 8. So I'm going to jump to chapter 8 because, to chapter 7. Chapter 7, and I'm going to do 7.2 and 7.3 and 7.4. So that'd be the plan. We have 6 more class meetings left before our final. The final will be in the first week of May. And I believe there are 6 more class meetings left, because the class meeting on Wednesday before the final will be just a review, just like what we did with the, thank you, that we did with a midterm. So final will be analogous to the midterm. 2 questions. I know in the midterm question 1 had lots of parts. No, it's not going to happen on the final. On the final, I'll have problem number 1, just 1 part. Problem number 2, just 1 part. That's all. So we'll discuss that when we get closer to the review day. And again, I'm going to look at section 6.2 next week, and then move to chapter 7 and do those 3 underlined sections. That's our goal for this class. And I think we're doing pretty well so far. So if you ever want to send me any extra work, I always welcome. People keep sending it to me every once in a while, and this is great. I always accept it. So please do it over weekend if you feel like it. If not, these problems I know a little bit longer, so you don't have to. So anyways, I'm gonna end this today without a quiz. So I'll let you go and enjoy the weekend. I'm gonna stop recording as well. So if you have any questions,